Bismillahirrahmanirrahim. Hello everyone. This is another StaadPro tutorial. In this tutorial, I want to model a reinforcement concrete moment from structure. So this is the structure plan, and we have 4 bays in the x direction and 3 bays in the y direction. Each bay has 6 meters, and in the y direction, each bay has 5 meters. So we have an opening in this area. For the primary design, we assume to have a 40 by 40 centimeters column, and we have 60 by 40 centimeters beam, and also a slab approximately 20 centimeters. So we intend to apply this dead load to the structure. We considering to design under seismic load. So this seismic parameter is getting taken from the earthquake hazard map, and it's usually using in the United States. So, but you also can give your own or local data. This is the structure parameters for the, we suppose this is an intermediate reinforcement moment structure. So we can get this data from the code AC7. So for the AC giving 5, 3, and 4.5, and it's applicable for 2 seismic design category, but not applicable for other one. So finally, we will use the RCDC detailing software. So we'll design the H elements and considering the detailing as well. So we're going to StaadPro, and we have 2 options to model: physical and analytical. So we're using analytical, and I can code RC building, and I create the model. So I can use wizard, which is quite fast, and using frame, and in the frame I can give the length is 24 meters h, so totally 4 bays, and the height is 70 meters, which is 5 stories, h stories 3.4 meters. So the length is, the width is 15 meters, totally 3 bays. And apply. Okay. Now the first, I will go to the one of the view, top view, and I want to delete these beams. Press the delete command, and you can delete. And so we deleted these parts, and now I want to select this one. So I want to duplicate using geometry this command, repeat in the X command 3 meters. So which is creating the this beam and the column for the opening area. If I go back to the view 3D, and you can see we created this one. Now next, I can go to the defined materials. First, linear properties. We define properties. Column. The column is rectangle, 40 by 0.4, 0.4 at, and the beam is 60 by 40. So this is closed, and we need to define thickness for the slab 0.2 at, and we can go to the column, and from the geometry you can come to the here beam and just select vertical or Y and apply the selected beams to the section to the beam. Now next, I can go to the second parts and going to the again geometry, and here in the geometry I have to select beam. In the select, go to beam. This is beam, and this time I'm going to select parallel X and parallel to Z. So I'm going to assign them to the selected beams. So we already selected this beam, and I can go to the geometry in the plate. This is a function called infill plate. So this plate will create it based on the this is 60 plate is created based on the boundary beams. So I can go to back to the select, and now I want to select all plates. So the plate is selected, and I'm gonna go to plate again because I should be on that again, and I want to assign this to the giving slabs. So if I go to rendering, so you can see, so this is the entire structure modeling. So but I wanna delete the the secondary the opening. So I can go to the one of the, let me right click. You can go to right click and it's called cursor. So I want to select plate. So I can go to the top view. uh, I can go to the top view or this command. I want to select this one. I'm gonna delete, press delete. So one plate. If I go again, and the second plate, again. So totally we have about 4 or 5. So now there is no more plate. If I go to view, and you can see in a 3D and doing a rendering. So this one is deleted, and we have to create again one plate here. So I can and now we want to draw one plate here. So I'm going to right click here and I'm going to select called plate cursor and plate, and I want to select this one. If I go to the 3D view, you can see one plate is selected. So I use a geometric this command again, and I want to rotate to minus in x direction -3. Now you can see that plate is extended to this area as well. Go back to rendering, and you can see the last floor is closed. Now we finished the modeling first part, and I'm going to the create some support. So go to the support, and I want to create a support. So we assume that the bottom is fixed, and it's a fixed support. I can go to the view. Let me go to the front view, and you can use cursor to assign. So I'm going to selecting this bottom, and here is, I'm going to assign it. So if I go back to the 3D view, and you can see we assign. So the last part is the loading part. You can go to the loading, and we should define first some reference load. I'm gonna add reference load. So we have the reference load is date load. I can call it DL, and the second is live load, LM, and we have these two reference load. And the second, in this seismic definition, I want to define the seismic using ASC 716. This is 16, and I can give these parameters manually in case if you are in the United States, so then you can give the code. So I'm gonna clean this data. So when I clean this data, so I'm giving this data is 1.2. Let me check it. 1.2 and 0.8. So this is approximate number, and here is 8.2. So we assume that the long period is 8 seconds. The importing factor is 1, and this is 5. This is also 5xy, and assuming the soil is deep soil, and the other parameter can be calculated automatically by a program. So now we define this seismic load. So I should create one more thing, reference load. So that means the program will get the mass of the structure or the weight of the structure from the reference load. So we're considering 100% of the date load and 25% and 25% of the live load. So now in the y direction, okay, and now we define this reference load for the structure. Now here is I should define this load to the structure as well. So I'm going to call add date load, so it's self load, and the second is the floor load. So the floor load is date load is 1.4 kilonewton per square meters. I'm going to give it 1 minus 1.4 square meters. So the total height is if we do not considering the roof loads, so if we considering uniform, so then we can give the main height of the structure. So the main height is 17 meters. If we want to consider here and then changing this one, so for the simplicity we can consider the roof and other story is equal. So I'm going to call add. Now we have these two loads. I'm going to call first these are two view, assign, and also the save. In the date load, we can consider that one. So minus 2.5. So minimum is we want to reduce 3.4 meters. So we have now we have 13.6 meters, which is this floor. So I'm gonna call add, and again the same, but from starting from this point to 16, and this is 13.6, and this one is the last is 70, but we want to consider 1 kilonewtons per square. So now you can see this load. So this load is adding to here, and the second one is just this blue one. Now we finish the reference load. If I want to, the program should calculate, and I can come to the analysis. Analysis and design command. Here is a command which is called, here in the loading, and it's called mass model generator. If I press this, the program automatically will calculate, but previously we have defined these two load, so we don't the program automatically will calculate this one. So we go again to the loading, and in the loading I should define a load case which is seismic load. So I considering that called seismic H, and I can call it EX and EY, easy. Now in the same load case we should consider the previous date loads to consider in the combination when we want to create combination. So this is the earthquake load, and also the date load and flow loads also considered. So now again going to here, creating date load, again called DL, and live load LL. So we have the design load is this one. So go to the X, and in the X we define seismic factor and the seismic load factor, so it's 1 positive. And we go to the Y direction, Z direction, and this time go to select again seismic load but Z direction. We can considering the positive negative, so but the program when we define the automatic combination, so the program automatically put 1 minus to this load, so that's not necessary in some cases. But if you have manual load combination, so you have to consider the minus to your load case. Now in the date load, again I go to back to the date load, so self load is the entire structure, and the flow load and flow load is minus 1.4, and we didn't considering the roof load, so it's equal, so let's be 70 meters. Going to add, and the last one is the live load, and in the live load we just have flow load, so we have a minus 2.5 from 0 to 13.6, and going to add, and the second is 1 kilonewtons from this number, I put it top to 17. And now you can see again, and this is the blue one and this is the green one. So we have, so now it's blue one and top is green one, and we have the entire is green one, blue one, and it's going to see. I'm going to assign to the view. So now the entire loading is completed. So the last thing is I'm going to call add a combination. So go to combination. So this is reinforcement concrete. We can create some combination, or later we can create combination in the advanced concrete design software. So I can select here list ACI 2002, or we can considering the AC7, and it will create for us different load combination. So you can see it's a -1 is added. So I'm called add, so we can see the minus is automatically added. Now we are finished, and we can go to the analysis. And in the analysis I want to define a command, so I'm called all, and I'm going to run the analysis. Save it. Yeah, it's start to design that, analyze the structure. So we can first, let's go to the some output, go to the post-processing, and if I go there, so you can see, we have this one, and I want to enable the automatic scaling, so the shear bending, stress torsion, and apply, and it's gonna okay. And you can see the first displacement here and during the X, and this is the horizontal displacement. Beam result, this is the moment, and you can see the displacement in the distance of this one, and finally in the height. We can go to the top during the combination, and also we can go to see some other plate results. We can go to let's go to see the one mesh stress. Okay, and you can see this one. So we finish here, and we want to design. So if I considering the design here, it's not possible, so we're gonna using advanced concrete design here. So the program will start, and now the RCDC software is launched, and we can give the name. Let's go to column design, and give the client name, and give the change the code. I use ACI and I'm using a metric, and here I should select column. So now you can see that data is imported to the RCDC software from the previous analyzed structure. Okay, now here is the entire column, and you can see this is the column. So what I want to do is I want to change the concrete is to 35, and using concrete 35, 35. The steel is using 460, 460. So the cover is okay, that 50 centimeters, 50 millimeters, and in the setting you can change some other parameters. So for this tutorial, I will assume this is you can see which seismic category design you want. So mine is intermediate, so I can use B. And also the other parts in reinforcement setting, so you can considering the minimum should be 1%, so the maximum should be 4%. I can change this one, and also the which rebar number you want, so utilize, and you considering these OOPs or using tile or anything else. So I assume this is okay as a default. And next I wanna go to run the design, and it's require me to define the loads. I can define the load is EX, and this is EZ, and this is dead load, and this is live load. So I can add these four. I can so now we have these four loads for the column, which is live load, dead load, and also now okay, and we have to give the combination. I can apply the combination from my analysis, so it will automatically select the critical combination, and okay, and the program start to design. So it's called auto designing column. So now starting the designing columns, and now here we can see this number of the column didn't pass. So in the last floor these columns, and second floor is one, and finally this column. So what we can do is we can manually redesign them. So let me redesign one of them. I can go to here, it's called redesign section. You can come here and check. Let me change the size 500 and 500, and I can press this one called redesign. So now this is design, and you can see the flexural and axial capacities is passed, which use this critical combination. Now I can accept this one, select accept. So the first is now passed, and I can go to the second one, So the second one, I can go to here and let's go to again redesign. So changing this thickness and redesign it, and it is passed as well, and I'm going to accept this. So now you can see the new data is giving. So what we can finish like this the entire columns. If I use manually, it is quite difficult. So what is the correct way? So we should change our cross section in the model, the exact model. If I go to back to the if I close this and I go to the StaadPro, and I should use like two floor is be 500 by 500 or 600 by 400, and two floor should be 40 by 500. So I should distribute the mass like in the bottom is large and the top is small. So that will be quite fast. So this column is not passed, so we can redesign here as well. Like here we can go again and changing the cross section. Let's go to simplicity. I'm considering both side 500 by 500, so I can go to redesign, and you can see the amounts of rebar, everything is changed, and you can see I have solved this for in the first floor. Now the second floor is also, you can change them as well. Let's go to the second floor, and I'm gonna column 2, and I want to use this one 450, and using 450. So I'm gonna redesign this, and this is also passed. I'm gonna accept it, and you can see C2 is passed, become green. So like this you can finish the entire columns. So if I do this manually, it takes quite a bit time. So what we're gonna do is I wanna go to turn off this. I'm gonna close it. So I already save it, and I should go back to the StaadPro here. It's called StaadPro, and I go to the properties, go to the in the properties I can change the column automatically. Let me define that column is that column should be 0.50 by 0.50. So I'm gonna call it add, or so here I can go to edit that column, and this time I'm gonna 50 by 50. It's called change. So we finished, and I changed it. So what I'm gonna do is going to again run the analysis, and the analysis completed, and I'm going to again to the design RCDC, and now again I want to column cast, so you can give it changing the ACI and using ACI 19, and you can select column. So it's importing the data, will take a while. Now again we have this column, and you can see we have this column again, and I can go to change the concrete to 35 and 35. So there still is this 420 is okay, and I want to go to the setting, and this time I want to considering perform called ductile design. So ductile design, which is means intermediate, which you give the response modification factor that are, so it is 5, and you can considering that from here you can see that you can design in a B and C. You can change this one to PC, so the B is okay for me, and that's okay. And go to auto design, and they ask me the load, so I give the load, and this is X, and this is Z, and this is the live load, the dead load, and this is the live load, and like this okay, and we can assign the combination from the analysis, and okay, and it start to design the column. And this is the result. Unfortunately, the entire column is passed. So, but this method is not correct because we should use uh, some different cross section for the structure. Now we can see the percentage of the rebar and also the capacity ratio. So the entire column is passed. So what we're gonna do is we want to create some BBS, and we're gonna go to create a BBS. You can see we can consider the entire column. So maximum rebar length, and you can change also some things. I'm going to change it as automatic as a default. Now the VBS is created because there is a significant columns, so it will take some time. And now here is the VBS, and you can select, go to zoom and zoom out, and you can see the each column, bill of quantities, and so it's quite large. It's in a DXF file. So here is the let's see which column is this one, and you can see the name of the column going to be here. This is the column, and you can see level. So this is the reinforcement rebar in the top stories, and okay, we can now save it. Oh, first we should save the project, and I'm gonna save it. So the project is saved, and I'm gonna save as a DXF file. And now you can see. Now here, ask me save a DXF file. I'm gonna call it column BBS. So now yes, you can DXF file, and I have selected. So like this, you can then you can go to the again to the DXF file, and you can edit, and also you can check everything. So we finished the first part, and I'm going to take a new one. So I select a new one, and this time I'm going to design called beam design, and you can give this number, and again just using ACI 19 record, and this time I'm going to using beam. So you can select which just you considering one floor or second floor or entire floor. So for the let's make a little faster, just one floor is okay for me, and I'm going to using that first floor beams, and it will import the data quite fast. So this is the beam, and you can see H beam here. And so what we're gonna do is we can go to the auto design. The same, we can give this earthquake load, and we're gonna add it. And this one is the Z, and we're gonna add. This is the dead load, and this is the live load. And we can add it. So I'm gonna OK, and we again go to add the combination from analysis, and it will program will define for us the deflection, and also we can consider the top cover, and it start to design for you. Now here is the result. So the entire beam is designed, the first floor, so all these passed, and we can go to here generate BBS and see. So we can considering all grids and generate OK. So, and it's generating BBS, displaying BBS, and now here is the beam design. So this is the reinforcement configuration, and you can see each area, and here is the BBS table, and here is the total length of the rebar and also the weight of the rebar. And you can then first save it, and the second is you can go to save a DXF file, and we have a column, and this is going to be beam. So beam, save it. So we can do some edit in the DXF or AutoCAD file. So now we finished, and I'm going to back to new, and this is the last part, which is going to design the slab. So we call it slab design, and again using the same client, and this time I'm going to call slab. So now again you ask me which floor you want, so just list the first floor. You can design simultaneously the entire structure, but for this tutorial it is quite time consuming, so we want to take it faster. So now this is the slab, and you can see this is the slab, and what we're gonna do is we want to define the load. So the imposed dead load, so we're giving minus 0.5, and the live load is going to be minus 2.5. Yeah, we can copy and paste to entire structure, and this is the thickness is 200 millimeter. So I'm going to copy this and to entire structure. So we can sometimes considering that in case if you want to reduce the top of the slab, you can add some parameters. So otherwise this is it. So, and I can go to run. You also have choice to change the parameters. So I'm going to go to design and program start designing. Because of the time, so I ignore those settings. So you can check those things and you can redesign. So now it's finished, and we can go to create a BB. Now this is the BBS we just created here. Processing data. So it's finished, and we can go to see the rebar configuration. So we have longitudinal, horizontal, vertical, top, bottom, and also we can create some. We also can draw some section as well. It's called slab section, and we can create which slab you want, and I'm gonna call it a number of slab. So let me this is number if I giving 7, it's going to be here. You can see and section mark if you're going to mark giving mark going to be A. Should be S. Okay, then you can give a number 1 here is you can select this slab 1, automatically it will taking this one, and we can draw it. So these are other parameters is called left mark section should be like A, and we're gonna call it A. This is called the thickness is 200. The left side is 200, and mark is called A, and 200 and 200. So I'm gonna draw, and you can see the first slab is created. So like this you can create the section for each slab. Then we can save the model and also create here I can call it slab BBS. So I go save it. So this is the end of the tutorial, and we finally finished the detailing and also the analysis and design everything. So like this you can model any structure, and this RCDC also improved too much, and it can create a lot of output for you. Thank you for watching. If you have any question, please put in the comment, and if you think this is value to subscribe my channel and like, comment, share. See you next time.